Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
If you've ever imagined what a genius might look like, chances are you picture someone in a white lab coat, serious expression, furiously scribbling formulas on a blackboard with a piece of chalk. But if you were to meet Richard Feynman, that image would quickly shatter. Feynman didn't fit that mold at all. In fact, he was more the type to be found banging a drum outside the lab, chatting about physics while sipping a drink at the bar, and even calling out authorities to their face during academic conferences. He wasn't fond of being called a genius. Instead, he preferred to describe himself as the guy who keeps asking why. This mindset, his motto, was what transformed humanity's understanding of physics. Feynman's story is nothing short of a disruptive, underdog legend in the field of physics. His thinking was never confined by standardized textbooks, nor was he ever pressured by the voices of authority. Rather, he questioned everything, approached the world from the perspective of an outsider, and dared to challenge the most trusted truths, even the most revered scientists. While others might have blindly memorized formulas, Feynman would ask, "Why are you doing this? How did you arrive at this conclusion?" His approach to exploring physics was far from conventional. It was like embarking on an adventure, full of exploration and wonder. For Feynman, physics was not about rigid equations but about the thrill of discovery, the unknown, and the process itself. But, as you can imagine, Feynman's approach wasn't always appreciated. He often humorously remarked that the scientific community sometimes resembled a stiff, outdated temple where scholars sat high above, simply repeating what others had already said, while true innovation and exploration were suppressed by these authorities. And Feynman was the one who came in to disrupt that order. One of his famous quotes is, "If you can't explain something in a way that a first grader could understand, then you probably don't fully understand it yourself." This spirit of challenging tradition and daring to question established norms made Feynman a far cry from the stereotypical image of a scientist. He wasn't the somber, rational scholar you might expect. Instead, he was a lively, smiling individual who loved to break down complex physics into simpler, more fun pieces, and often did so with humor. Feynman turned the language of physics into something more approachable and engaging, showing the world that science wasn't an elite, high-up endeavor, but rather a grand adventure that anyone could join. Richard Feynman was born in 1918 in New York to a family with modest means. His father was not a scientist, but a highly intelligent man who nurtured his children's curiosity in a unique way, rather than providing answers. Feynman's father encouraged his children to ask questions. Feynman often recalled how his father would point to a bird outside the window and ask, "It's not important what its name is. What matters is what it's doing." This became Feynman's life motto. From a young age, Feynman was not content with knowing that, but always wanted to understand why. While other children played with noisy toys, Feynman was more interested in dismantling the family radio to figure out how this seemingly simple device worked. Feynman didn't just want things to work, he wanted to understand why they worked. This habit of questioning everything, of keeping a curious mind, was ingrained in him from a very young age. Feynman's curiosity turned him into the neighborhood's go-to repairman. People would often ask him to fix their broken appliances, and Feynman could not only fix them but also explain the entire repair process in detail. For him, the world was not a given. It was like a machine that could always be taken apart and understood. Behind every question of "how does it work?" lay a world of unknowns. This lifelong curiosity and desire to explore the why behind phenomena became Feynman's driving force. He never viewed the world as a black box but believed it could be deconstructed and understood. In many ways, he saw science as the tool to demystify the world. As Feynman entered the Massachusetts Institute of Technology, MIT, his path of exploration entered a new phase. Here, he encountered advanced physics knowledge and confronted the traditional authority of academia. MIT, one of the top universities in the United States, taught physics in a standardized manner. where students memorized formulas and theories. But Feynman wasn't satisfied with this surface-level knowledge. He always maintained a mindset of questioning everything. In MIT classrooms, Feynman often stood out as a rebel, while others blindly followed formulas. He asked, "How did you come to this conclusion?" He wasn't concerned with who said it but focused on how it was derived. This approach made him seem like an outsider, a troublemaker who often made professors uncomfortable with his questions. Yet, this unique attitude helped him stand out. Professors, though sometimes flustered by his questions, began to recognize Feynman's extraordinary mind, one that was constantly probing, questioning, and challenging every boundary of knowledge. Upon entering Princeton University, Feynman encountered his life-changing mentor, John Wheeler, a well-known physicist and creative thinker. Wheeler encouraged students to boldly make guesses and theorize from fundamental principles. Under Wheeler's guidance, Feynman dared to propose his groundbreaking ideas, especially the path integral formulation that would later become a cornerstone of quantum mechanics. Feynman and Wheeler engaged in lively discussions, often proposing seemingly absurd yet innovative hypotheses about black holes, time, and particle paths. This freedom of thought greatly inspired Feynman, pushing him to break away from textbook constraints and explore the raw, fundamental truths of physics. It was here that he learned to disregard traditional frameworks and pursue the most basic, essential principles of physics. By this point, Feynman was no longer content with learning from books. His worldview shifted. Physics was no longer a dry exercise of symbolic calculations, but a continuous journey of questioning and discovery. In the early 1940s, Feynman's life took a significant turn. He met Arlene, a brilliant and humorous young woman who would become not only his lover but an integral part of his life. However, this relationship wasn't born out of perfect harmony but was deeply shaped by life's uncertainty, especially Arlene's diagnosis with tuberculosis, a disease that, at the time, was almost always fatal. Despite Arlene's illness, she remained upbeat and humorous, and the two of them spent countless hours together discussing science, philosophy, and the meaning of life. Even in the hospital, they would talk about the mysteries of quantum mechanics, as though no illness or uncertainty could diminish their curiosity about the world. Feynman later reflected that while he understood how physics could describe the laws of the universe, he could never predict or fully understand the complexities of emotions in life. Facing Arlene's illness, he realized that life was far more unpredictable and elusive than any formula in physics. Science could explain the phenomena of the universe but could not provide simple answers to personal challenges. Despite the difficult circumstances, Feynman and Arlene married and spent their time together, navigating the uncertainties of life. Tragically, Arlene passed away in 1945. Her death profoundly impacted Feynman, teaching him that life, unlike physics formulas, was uncontrollable and fragile. After this experience, Feynman's view on life shifted drastically. He began to see science not only as a way to solve problems but as a way to cope with uncertainty and accept life's unpredictability. In 1943, as World War II escalated, Richard Feynman was recruited to join the Manhattan Project, the U.S. initiative to develop the atomic bomb. This experience not only shaped his career in ways that would last a lifetime but also brought him face to face with the brutal realities of war and destruction. It was the first time he truly understood how science could shift from a pursuit of knowledge to a potential threat to human existence. Feynman's experience, in this sense, was shared by many scientists who participated in that project. Feynman, who had worked in theoretical physics, was suddenly thrust into a world of high secrecy, witnessing firsthand the birth of the atomic bomb. At first, he believed his work was simply a pursuit of scientific discovery, but it didn't take long for him to realize that his efforts might contribute to the most destructive weapon ever known to humanity. From a purely scientific perspective, the project was an incredible breakthrough, but morally and humanely, Feynman felt deeply uneasy. He later expressed that during that time, he experienced an inner conflict. As a scientist, he had to complete the task, but as a human being, he had to question the consequences of his work. Imagine, He said, "If the atomic bomb hadn't existed, what would the world look like today? Would we still be in World War II? Or would we already be in the third?" Yet, Feynman's approach to work remained as unorthodox as ever. In a highly secretive environment, he did something that was decidedly not secret. He challenged the lab's security protocols and even cracked the safes of his colleagues. With this rebellious act, he proved a harsh truth: no system, no matter how securely designed, can guarantee absolute safety. This willingness to challenge authority, even in the most controlled environments, set Feynman apart from his peers. He was not just a thinker, he was a disruptor. When the first atomic bomb was detonated on July 16, 1945, many in the lab cheered, convinced they had achieved a monumental scientific victory. Feynman, however, remained silent. He understood that this scientific achievement would forever alter global politics. Though he had not fought in the war, the use of the atomic bomb had rewritten the post-war world order. Science was no longer just about uncovering truths, it was now a tool for world-altering, even world-destroying, change. This realization filled Feynman with a sense of guilt and ambivalence. He began to ask himself, if we can do all these things, then what should we do? This pivotal experience dramatically shifted Feynman's worldview. He realized that science wasn't just an academic pursuit, it was a social responsibility. As scientists, it wasn't enough to discover truths, they had to be responsible for how those truths were used and, just as importantly, how they could be misused. From then on, Feynman's role evolved. He became not only a researcher but also a philosopher contemplating the ethics of science. He began to ask, does scientific progress always align with human well-being? He wondered, when scientific discoveries push the limits, do they inadvertently bring humanity closer to the edge of destruction? After the war, Feynman returned to academia, but the scientist who returned was no longer the same naive student. The burden of understanding the immense power of science weighed heavily on him, and he became acutely aware of the moral responsibility that came with this knowledge. Upon returning to Princeton University, Feynman set out to redefine the way physics was expressed. He sought to make it more transparent and accessible. One of Feynman's greatest contributions was the invention of the Feynman diagram, a tool that transformed complex calculations into simple visual representations. For physicists, quantum electrodynamics (QED) involved intricate mathematical computations. Feynman diagrams made these abstract formulas more intuitive and manageable, allowing physicists to see how particles interacted and moved at the quantum level. This innovation revolutionized not just QED, but the very way physicists approached problems, making physics feel less like a complex puzzle and more like an interactive map of the universe. Feynman was not content with simply simplifying equations, he wanted to make physics an adventure. For him, physics wasn't just about equations and formulas, it was about stoking the flames of curiosity. With his Feynman diagrams and other inventive teaching methods, he sought to make physics feel less like an impersonal, rigid discipline and more like an engaging, exciting story. He often used humor in his lectures to break down complex scientific concepts, turning what could be a dry academic pursuit into something lively and enjoyable. This approach made Feynman an immensely popular professor. His students didn't flock to his lectures because they were easier, they came because Feynman turned learning into an intellectual adventure. To them, physics was no longer about memorizing formulas, it was about embarking on a quest to understand the universe and the unknown. Feynman made it clear that science wasn't just for experts, it was a deep, ongoing dialogue that anyone could join. Feynman's teaching revolutionized the way science was taught and understood, challenging traditional notions of academia and even the very structure of education. His success proved that science didn't have to be aloof or sterile. It could be something everyone could relate to and understand, as long as it was presented with passion and a sense of wonder. As Feynman's academic fame grew, he became a public figure. He wasn't interested in the traditional confines of academia. His unconventional ideas and personality attracted many young people. His lectures were filled with humor and insights, offering a fresh perspective on how to see the world. His approach to teaching and thinking began to influence not only the physics community but a broad range of fields. But Feynman never indulged in the prestige that came with academic authority. Instead, he harbored a strong anti-authoritarian streak. To Feynman, authority wasn't just something to be respected, it was something to be questioned. He refused to accept theorems that were presented as unquestionable truths in textbooks. Instead, he encouraged others to question and think critically. He once said, "I don't think authority is always right. Authority can be wrong, too." This wasn't a blanket rejection of authority, rather, Feynman believed that progress in science came through doubt and inquiry, not blind obedience. This mindset explained why Feynman often presented uncomfortable, challenging questions in public forums. He didn't accept common knowledge easily, nor did he settle for conventional ways of thinking. Whether in university lectures or in public speeches, Feynman maintained a provocative stance, encouraging people to think for themselves. He made bold statements in public appearances. For example, during a speech on American national television, Feynman offered a stunning view on what was commonly believed to be the mystical nature of science. Science is not some mysterious black box. Anyone can understand it. He used vivid metaphors to explain complicated physics concepts, turning what could have been dry, academic content into relatable stories. Feynman's fearless critique of authority and his refusal to adhere to academic norms earned him the reputation of a public intellectual. His influence spread far beyond academia. In an era when information didn't flow as quickly as it does today, Feynman used books, lectures, and television to bring complex physics to the general public. His works, the Feynman Lectures on Physics and Surely You're Joking, Mr. Feynman, became landmark texts not only in the scientific community but also for millions of ordinary people seeking a fresh way to view the world. His public outreach transformed the way people understood science, making it more accessible, engaging, and enjoyable for all. Feynman didn't just explain science, he made it fun, human, and deeply relevant to the lives of people everywhere. Through his work, he inspired generations to approach knowledge not as a rigid structure, but as an ongoing conversation that anyone could be a part of. On January 28, 1986, the U.S. Space Shuttle Challenger tragically exploded just 73 seconds after liftoff, killing all 7 astronauts aboard. This catastrophe shook the world to its core. Richard Feynman was appointed as a member of the Presidential Commission tasked with investigating the disaster and uncovering its cause. However, this incident not only thrust Feynman back into the public eye but also placed him in the midst of a much greater moral dilemma, one that involved the intersection of science, technology, responsibility, and institutional failure. Unlike other members of the commission who relied on complex official reports and expert testimonies, Feynman took a refreshingly straightforward approach to uncover the root cause of the disaster. In one meeting, he conducted a simple yet cutting experiment that revealed the fundamental issue: the O-rings used in the shuttle's boosters had become brittle due to low temperatures, leading to a leak that ultimately caused the explosion. To prove this, Feynman immersed an O-ring in ice water, and it quickly lost its elasticity, unable to function properly. Through this demonstration, Feynman revealed a simple truth that had been obscured by a complex web of bureaucracy and expert opinions. His direct approach exposed the true cause of the shuttle disaster. It wasn't an inevitable technical failure, but a managerial oversight and disregard for safety. This act of scientific transparency not only made the public aware of the real issue but also critiqued the NASA management for its negligence and opacity. Feynman's actions brought the issue into the light, helping the world see that the disaster was preventable, if only proper attention had been paid to the problem. This investigation showcased Feynman's unwavering commitment to scientific integrity, not only pursuing truth but also ensuring accountability. In the face of authority and bureaucracy, Feynman was never afraid to challenge the system. His actions in challenging the poor decisions made by NASA management led to significant reforms within the agency. This solidified Feynman's image in the public eye not just as a scientist, but as a guardian of truth in the scientific community, willing to speak out against injustice and expose the inconvenient facts. Even in his later years, as he grappled with cancer, Feynman never stopped his intellectual pursuits. His physical health deteriorating, He continued to teach, maintained his trademark humor, and remained active in his beloved field of science. He knew time was no longer on his side, but he still believed that the true meaning of life was not in being remembered but in the journey of questioning, the joy of exploration. Feynman often said, "The meaning of life is not to find the ultimate answer, but to enjoy the process of exploration." He maintained that science was not about obtaining perfect, final answers but about the continuous questioning and discovery. For him, the real beauty of science lay in its boundless potential, not in the certainties it delivered. Feynman was not just a physicist, he was a thinker exploring the deeper philosophy of knowledge itself. As Feynman entered his final years, he continued to challenge our conventional understanding of the world. He made us realize that science is not just about exploring the external world but also about reflecting deeply on our own understanding. He taught us that even if we never find all the answers, or can never fully grasp the complexities of the world, the process of exploration itself is what truly matters. It's this ongoing pursuit that keeps us curious and passionate about life. In the last years of his life, Feynman still injected humor into his academic work. He was the scientist who would crack jokes in class, refusing to be confined by academic frameworks. He was the question machine, unwilling to accept anything at face value. Feynman wasn't afraid of death because he understood that death couldn't take away his curiosity and critical spirit. As he once put it, "Uncertainty is a part of life, and it's this very uncertainty that drives exploration." Feynman passed away from cancer in 1988. At the age of 69, his death marked the end of an era, but his ideas continue to resonate across the globe. He not only transformed the field of physics but also influenced the way we approach education, science communication, and philosophical thinking. His first principles approach, his spirit of inquiry, and his anti-authoritarian stance have become core components of modern thinking. Feynman revolutionized the way physics was made accessible to the public, using humor to make complex concepts understandable. Today, young scientists, engineers, programmers, and even entrepreneurs practice Feynman's thinking, starting from the most fundamental principles and using them to reimagine the world. His method of starting from the basics, asking questions, and exploring from those questions has become a foundational approach to innovation. His legacy goes beyond physics. Feynman's methods have become invaluable tools for educators, entrepreneurs, and thinkers worldwide. His influence reaches far beyond the scientific community, becoming a part of global culture. He taught us that true wisdom isn't about possessing knowledge, it's about being brave enough to face uncertainty, to ask questions, and to admit when we don't know. Feynman's thinking not only impacted physics research but also paved the way for future technologies, especially in the field of quantum computing. Looking back at his contributions, the Feynman diagram is not just a tool for simplifying physical calculations, it offered a new lens for understanding the quantum world. Through this graphical representation, Feynman opened a quantum window for future scientists, and at its core was his deep understanding of path integrals. Quantum mechanics complexity has long confounded physicists. How do particles move through space? How do they choose their paths in an instant? These questions are filled with uncertainty and are difficult to express in traditional mathematical terms. However, Feynman diagrams, with their simplicity, transformed the interactions and paths of particles into easy-to-understand visuals, bringing these abstract quantum processes into the realm of the comprehensible. This innovative approach not only made it easier for physicists to understand quantum phenomena, but it also laid the foundation for the eventual birth of quantum computers. Quantum computing, based on the principles of quantum mechanics, utilizes the superposition and entanglement of particles to perform computations, greatly enhancing computational power. While quantum computing is still in its early stages, Feynman's way of thinking and his intuitive grasp of the quantum world have provided theoretical support for the development of modern quantum technologies. In fact, as early as 1981, Feynman proposed a revolutionary idea: the true nature of computation is quantum computation. He recognized that traditional computers could not efficiently simulate quantum phenomena because they were based on classical physics principles. It was only a quantum computer that could perfectly simulate the natural world. He said, "We need a new kind of computer that can simulate the quantum world itself." Today, as quantum computing advances rapidly, we see Feynman's ideas coming to fruition. While quantum computers are still far from widespread use, tech giants like Google and IBM, as well as numerous startups, are working toward the day Feynman predicted, when quantum computers will not only be tools for scientific research but will transform everyday life. Feynman's contributions extend far beyond physics. His approach to thinking has permeated the cutting edge of technology and modern computer science. For researchers in quantum computing, Feynman diagrams are not merely tools for calculation, they represent a mindset of exploration and breaking through conventional thinking. Feynman's influence stretches far beyond physics, reaching into technology, education, and innovation. He taught people not just science, but an attitude toward life, one that values curiosity, embraces questioning, and welcomes uncertainty. In Silicon Valley, his ideas became the foundation of an innovation culture. Many tech founders, like Elon Musk of Tesla and the SpaceX team, have been deeply influenced by Feynman's approach to thinking. Their focus on first principles thinking aligns closely with Feynman's methodology. He taught us that true innovation doesn't come from fixing what's broken within existing frameworks but from reimagining the world from first principles. This is precisely what companies like Tesla and SpaceX have done, breaking through the technological bottlenecks of the past to create the next generation of electric vehicles and space technologies. Feynman's influence is not limited to entrepreneurs and scientists. His educational philosophy has injected fresh energy into education systems worldwide. Through his Feynman technique, he encouraged students to deeply understand concepts rather than merely memorize them, emphasizing the importance of teaching others to deepen one's own understanding. This method is not just applicable to physics but to any discipline. Today, more and more educators are adopting Feynman's teaching methods, encouraging students to learn actively and deeply by questioning everything. What's even more remarkable is that Feynman's spirit has become ingrained in global culture, serving as an indispensable thinking model. Whether in research, engineering, education, or creative industries, people are solving problems and pushing innovation using Feynman's approach. In today's interdisciplinary collaborations, especially in fields combining science, technology, art, and social studies, the shadow of Feynman's spirit is unmistakable, breaking from tradition, challenging conventions, and seeking the fundamental principles to build new ways of understanding. In fact, in this age of information overload and rapid change, Feynman's approach is more relevant than ever. Today, people often seek quick answers and instant results, but Feynman taught us that only through deep, careful thinking can we truly grasp the essence of the world. His ideas help us understand not only the physical world but also the uncertainties of life, reminding us to keep our curiosity alive and continue our search for truth in a fast-paced world. Richard Feynman's legacy extends far beyond his scientific contributions. He wasn't just a remarkable physicist, he was also a philosopher, an educator, and even a social thinker. He understood deeply that the boundaries between science and philosophy are not insurmountable, and that science is not an isolated domain, it is intrinsically connected to human life, culture, and society. Feynman's lifetime of exploration was not only dedicated to the study of physics, but also to a profound reflection on human cognition and the way we think. He taught us that science is not the ultimate answer, it is an ongoing process of human exploration and reflection. For Feynman, the greatest allure of science lay precisely in its uncertainty and its perpetual quest. Behind every scientific discovery lies a new question, and behind every theory, there are countless unknowns waiting to be uncovered. He repeatedly said, "The world is not understood, but continually explored." This statement not only sums up his view of science, but also his view of life. Feynman believed that while human understanding is limited, it is precisely this limitation that fuels our drive to explore the world. As he put it, life is not about finding the answer, but about enjoying the process of exploration. He never settled for existing knowledge systems, always starting from the most fundamental principles, questioning everything deemed self-evident. and re-evaluating every piece of knowledge. Feynman's spirit did not end with his death. On the contrary, his way of thinking continues to spread across the world and is applied in many fields, whether in physics, technology, education, or the exploration of social philosophy and human thought. Feynman's influence is everywhere. His legacy is not tied to any specific formula or theory, but to an open mindset and an unrelenting spirit of exploration. This very spirit is the driving force behind humanity's continuous progress. Feynman's story teaches us to never fear admitting that we don't know something, never fear failure, and never fear moving forward in uncertainty. He made us understand that science is not just about discovering facts, it is a process of doubting, questioning, exploring, and growing. Behind every question lies a spiritual awakening. It is this spirit of exploration that is the true source of human advancement. The life and career of Richard Feynman were marked by a deep exploration of the unknown. Not only did he change the face of physics, but he profoundly influenced global thought and culture. His legacy is not just the groundbreaking contributions he made to quantum mechanics, but also the spirit of inquiry and spirit of exploration that he established for all of humanity. Whether it was his light-hearted and humorous classes, his challenges to the norms of science, or his reflections on life and the world, Feynman showed us that, just like science, life is full of uncertainty, and it is this uncertainty that makes the exploration of the world so fascinating. He didn't just change physics, he changed how we understand knowledge and how we view the world. In the end, what Feynman left us with is the courage to always remain curious and never stop asking questions. Feynman's way of thinking and his attitude will continue to inspire future generations to move forward in an uncertain world, always curious, always questioning.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.